So one of the biggest challenges for autonomy in aviation is it's a completely new way to fly airplanes. So the system bench is a tool that allows us to go test what we're building, as we say at 1G, not flying around in an aircraft and doing our first testing there.
I believe that in order to develop new technology, you need to test it in simulation. It's available 24/7, it is safe, and you can iterate and change and try ideas that you cannot try it on the actual aircraft.
The system bench is significant because it'll be used by at least 3 teams: the systems team, the controls team, and eventually the human factors team. It will enable us to test the system before we go to the aircraft.
It brings together all of our hardware and software in both a development environment as well as a testing and integration environment. We verify that the requirements meet both performance goals, safety goals, and even edge case goals, where we're not really willing to test certain cases on an aircraft or in flight. We want to make sure that the system behaves the way we expect it to in case those cases ever pop up, because we can do everything we need to do right in the lab without having to put anyone in danger.
And then when we test on the bench, we go to the aircraft, and aircraft will be only to validate that everything is working. So we do not use the aircraft to experiment, try new things, or even collect data that can be done on the ground.
Starting with injecting data, we have a test GUI that we developed in-house. That sends data through the test interface unit, which is both hardware and software on the bench. And then that test interface unit runs cables out to the real system receivers that we're testing.
We have a full set of hardware that we put on the airplane. So all of it is real hardware, not simulations or lab assets or items that don't really look like the real thing. We're running the real thing in our system bench.
We are really building a real bench with a real equipment, so we can take validation and verification activities and produce evidence to comply with the means of compliance that is required by the regulators, whether it is the FAA or the CAA in New Zealand.
We could take the approach where we take software, we develop it, and take it straight to the aircraft, but it's a lot safer to run it through the system bench first. Yeah, you can write requirements, but once you actually plug pieces together, you're gonna find bugs, you're gonna find something, and you'll be able to get those corrected before you go to the aircraft to make it a safer flight test.
We have talent all over the country that's really good at this and not necessarily right here in one spot. So a lot of emphasis was placed on selecting hardware and tools that could be reused remotely and at any time of day. So the entire system can be operated from outside the lab here.
We have the cameras, you can power it up, shut it down, everything can happen remotely. So this was an additional investment, an additional step that I really didn't see before.